for during this period.
Doesn't matter. All right, so here we go. So this is a review, proofs, the stuff about the structure, about a proof, but two techniques. I want you to write those two things down because we're going to talk about that quite a bit as we go through proofs. Number one, technique. This is how we do proofs. If you wonder and you say, man, I don't know what to do when I get a proof, I'm giving you two techniques to do proofs. Number one, you look at the given information and then you have a conversation with yourself. You don't have to talk out loud so people don't think you're crazy. You're welcome to, but you don't have to. You have a conversation with yourself and you say, what can I conclude from the given information? Basically, you let the given information lead you to the next step. What can I conclude? Or you might even say, what does this mean? Or you might even ask yourself the question, why did they mean the people that created the problem, why did they give me that info? Does that make sense? So you're just having a conversation with yourself. You're trying to analyze the proof, and you're looking at the given information, and you're saying, why is it there? They're not going to mislead me. They're not giving me information I don't know. There's given information. What am I going to do with it? What can I conclude from it? I keep repeating myself because this is the exact conversation you need to have going on in your head. What's the given information? What does it mean? What can I conclude? Does that make sense? Now, you're going to get a lot of practice, and I'm going to do this very same thing with you quite a bit as we go through these. But you got to be able to have this conversation on your own with yourself as you do these proofs. What's the given information mean? What can I conclude? Okay? That's technique number one. Now, not every problem is really clear just by using technique number one. You might need to employ technique number two. And here's technique number two. Working backwards. Working backwards means we go to what we're trying to prove, and then we say, what must be true in order for that to be true? And then we work our way backwards. What must be true in order for that to be true? What must be true in order for that to be true? You see? And I work my way all the way back until maybe the given information or information that I have. So there's two techniques. Okay? I've got the one working from the given. I'm working my way down the proof. And I've got the one at the bottom. I'm working my way back up. Some proofs I might use both. Some I might only use step one. But eventually, these two techniques should allow you to understand what they're doing in the proof. Okay? All right, you guys got that down? Those are the two techniques. We're going to refer to those a lot. Those aren't in your book. The book doesn't teach this. Okay? This is what I've learned in 15 years of teaching geometry. These are the best ways to approach proofs. Okay? Best ways for students to understand how to look at them. Okay? All right, let's move on. So which proof did we do? Did we get any proofs done in that? I finished in different spots with different classes. So where did we finish with you guys on the proofs? Did we do number 8? We did not? Okay, let's just start fresh, and we're going to do number 8. Okay? Take a look at number 8, your turn, number 8, which is on page 143. All right, now let me catch up. I've got some pictures I want to do.
Why'd you go 43?
Oh. Okay, so here's the not a great picture because I'm not very good at these, but we'll do our best.
You don't have to write this on your book.
If it's already in your book, you don't need to write it. It's right there.
I just didn't know if
No.
you have to write in the book.
Oh yeah, no, write in the book. That's fine. If I say something that you think, oh, that's probably something I should remember, feel free to write it in your notes. Okay, so here I'm just getting the structure down. I'm kind of catching up with what the book has. This says that given triangle SVT is congruent to triangle SW2. This is how your mind should work, because this is how my mind works, and I'm trying to get you to think like this. As soon as I read triangle SVT is congruent to triangle SWT, you know what comes to my mind? And I want it to come to your mind? This. Bo, read this as I write it. Are congruent. Corresponding parts of congruent figures are congruent. Do you remember us talking about that on Tuesday? You actually wrote it. There was a box. If two figures are congruent, then the corresponding sides and the corresponding angles are also congruent. You remember writing that in your notes? That's what this means. So another way to write that is this. Nope. If you watched the video yesterday, while others were taking the PSAT, that's what I call it, PSAT. By the way, what did you guys think of it? Most people I've heard said that they thought the math part was pretty simple.
The second part of the math was kind of difficult.
One with the calculator?
Yeah,
I heard some people said that they thought the first reading comprehension was pretty tough.
yeah, they only gave us an hour to do like 27 questions and read like 6 short answers.
Yeah, they had trouble getting it done.
Yeah.
Yeah, I heard that.
Like one story, one.
Okay, someone told me that one of the math problems was very similar to a problem that we had done just in class, in geometry. It was looking at the triangles.
Yeah, it was.
Yeah, congruent angles or something. Yeah,
Boy told me, oh, no, never mind, that's SAT.
but they're similar. In fact, that's the purpose of the PSAT, is to prepare you for the SAT.
Oh, well, he said that, he thought you could have got a better grade than, if you would have taken, like, in the math portion, if you would have taken the sophomore year. Because he said, like, it wasn't, like, anything that he was thinking, like, this year.
That's where the preparation, that's what I've been trying to tell Andrew and my older kids. The preparation before, a lot of it's review. It's just to get you back acclimated. How do you solve a system of equations? How do you do these things your freshman and sophomore year? Because that's what a lot of the test is. And so freshmen, that is really important. When you're done with the PSAT, they actually give you access to Khan Academy, which has practice tests on it for free. So keep that in mind for the future. But anyway, so back here, so this is just an abbreviation. I don't mind if you use this. The video yesterday showed that you could use this. Corresponding parts of congruent figures are congruent. It's just an acronym. Okay? My mind went there. As soon as I saw that this triangle is congruent to that, then remember, how many parts are congruent? 6. 3 angles and 3 sides. Remember that? Okay? That comes from Tuesday. All right. Well, we're not done yet. Let's look at what else. They want us to write down what we're trying to prove. So I'm going to write that. We're trying to prove that ST bisects angle VSW. Okay, so let's go ahead and do our structure of our proof. We have statements. We have reasons. Usually statement number 1 is our given, so let's go ahead and write that in. Triangle SVT is congruent to triangle SWT. Now, I've kind of already done the technique number 1 where I've said, okay, what does the given information mean? Well, if two things are congruent, then corresponding parts are congruent. That's technique number 1 because I'm answering the question about it. Does that make sense? Okay. Well, let's look at technique number 2. What are we trying to prove? I may have used this illustration with you before, but I'm going to come back to it if I did. If not, I'll say it again. Andrew wants an allowance. There's 3 things he must do. clean his room, take out his trash, unload the dishwasher. If I think about that backwards, if Andrew got an allowance, that means he must have done these three things. That's working backwards. You see the difference? Okay. So, same thing here. If I work backwards, if I wanted to say that ST bisects angle VSW. Now let's look at angle VSW. I'm going to do something that I do recommend for some problems. Pull it out and look at it by itself. There's VSW. See how now that's just the angle. And then if ST bisects that, what must be true? Cuts it in half, that's right. Or I could say, if I know that these two angles are congruent, then I know I can conclude that ST is the bisector. Does that make sense? That's working backwards. We're there. Hopefully you guys see it. But if not, we're basically done the proof in our head without writing anything down. Do I know that these two angles are congruent? Yes, I do. They're corresponding parts of congruent figures. So step 2 of my proof is that angle VST is congruent to angle WST. And I don't mind if you do this. Corresponding parts, congruent figures are congruent. Just know what it means. You're going to use an abbreviation, know what it means. Corresponding parts of congruent figures are congruent. Okay, so now since I've said that these two angles are congruent, where are they? And in my picture, they're right here. Or like I showed over here, they're there and then. So then step 3, can I say what I'm trying to prove? Yeah, that's usually my last step. ST bisects angle VSW. Sometimes this reason's hard to come by, but it's the definition. I'm going to abbreviate that. Definition of angle, that's my angle symbol, bisector. I don't mind if you abbreviate. Proofs take a little time.
What is this? DEF.
N. Apostrophe N. That's an abbreviation for definition. Okay. Everyone understand that proof? We need to go over it again? All right, let's go ahead and look at number 9. Okay, so same page. Let's go to number 9. You already have the diagram. Let me make the two pictures, see if I can get them somewhat close. A, B, C, D, E, F, G, H. Given quad A, B, C, D is congruent to quad E, F, G, H. I think that's right. Yep. And also given is that AD is congruent, segment AD is congruent to segment CD. All that's given. All right, so where are we going? Well, we're trying to prove this. This is what we don't know, and we're trying to conclude or prove that AD is congruent to GH. So we know that AD is congruent to CD. We're trying to prove that AD is congruent to GH. All right, well, let's go ahead and set up our proof. Here's our structure, statements, reasons. This is called a 2-column proof. Here we go. Step 1. What's always our step 1? Our given information. Quad ABCD is congruent to quad EFGH, and AD is congruent to CD. And that's given. Okay, let's look at technique number 1, okay, which is why did they give us this given information? What does it mean? What can I conclude? All that kind of stuff. All right, so as soon as I know that two things are congruent, in my mind, I should be thinking corresponding parts of congruent figures are congruent. That's in my mind. You know, my mind as I'm thinking. Ah, yeah, corresponding parts of congruent figures. Right? I'm thinking it. Okay, so if those two figures are congruent, that means so are all the corresponding parts. Aha! So I can conclude, just from the given, I'm not doing anything with the proof right now, just from the given information, I can conclude that AD is congruent to EH. Well, doesn't the given information also tell me that AD is congruent to CD? Sure does. So I know that if this were a length of 8, then that has to be a length of 8. It's just a random length. I don't know what the length is. I'm just giving it a number. Well, if this is a length of 8, this has to be a length of 8. With me? Well, what does CD also equal? If the two quadrilaterals are congruent, what does CD equal? That's right. And that's also 8. Oh my goodness. Look at what we're trying to prove. That AD is congruent to GH. Didn't we just prove it? See, so I didn't have to use technique number 2. I just went straight from the given information, and I asked myself that question, what does the given information mean? Now I got to put it in the structure, okay? And sometimes this can be challenging for you because you're not used to doing it, okay? Let the given lead you to the next thing. So if this is where my mind went, that's probably what I want to use for my reason. AD is congruent to EH, and CD is congruent to GH. What are those? Those are corresponding parts. CPCFC. Now, okay, so here we go again. AD is congruent to EH. We know that AD is also congruent to CD, so therefore, by the transitive property, work our way all the way. Well, let's say the proof here. AD is congruent to GH. Can you see that? Sorry, let me make that a little clearer. AD is congruent to GH. What we're trying to prove, and my reason. Yeah. You're never going to have a problem that is inconclusive. Transitive. Now, the book would like they showed us on Tuesday, they may have, see how there are two parts to the given information? They may have split that up into 2 steps. And here's one thing, too, that you're going to learn. Bo might take 3 steps and it be completely right, and somebody else might take 4 and it be completely right. Okay? Sometimes there's more than one way to go about the proof as you lay it out. Okay? Everyone all right with that? All right. Here's your assignment. You're going to have a lot of time here in class. I want you to work on it. Try and get it done. 2 through 13, 16 through 18. There's only one proof. Do not skip it. Do it. Hope. It's right there. Page 144, 2 through 13, 16 through 18. All right, any questions? Because I'm going to post this on campus. We good? All right. Virtual students, hit me up if you have any questions.